Welcome to our short video 2 from McKenzie Technologies. In our first video, we introduced our aviation aerospace version of our wire integrity testing and tracing system. We showed it finding a short, accurately locating short in an aviation wiring harness on an aluminum test bed. We have the same test bed here, 2 sheets of aluminum, 2 aluminum platforms, our aviation wiring harness segment with the shielded wires, the shields of the wires tied together and contacting our chassis ground. Again, same wire, we have created a short in one of these wires where its metal shielding is contacting the core wire. This particular video we're dealing with shielding and obstructions, and we have 2 1/4-inch sheets of lead, one on top of each other obviously, that are crudely but electrically connected to our chassis ground, providing adequate shielding. So we will turn on our transmitter, connect our probe tip. We've already pre-selected the shorted wire and connected a pin adapter to it. We'll take our signal probe and connect to it, take our transmitter ground, connect to our chassis ground. Our short indicator comes on, indicating that indeed we are connected to a shorted wire. We take our tracer module, our Sherlock, power it on, and as before we can determine our wire's path by the LEDs that come on. We're over top of it. Now we can get down to it. Let's turn our sensitivity all the way up, and we can come down to approximately about a foot to our wire and adequately trace our wire's path. Now you'll notice that there's a lack of splatter or inductive coupling coming off of our aluminum base chassis. So we know where our wire is. In this video, we're going to, instead of using our green LED to determine our wire's path and the distance therein, we're going to come off and see how far we can and still trace our wire. We can use our red LED and the brightness of it to determine where our path is. As you see, we come off our path, our LED indicates when we are on our path. Our wire should be directly below our arrow, and we are off our wire's path, and there it indicates we are on. So as we trace through our wiring harness, we come upon our lead shield and we move through it, and we see that our LED goes away no matter what direction we go in. So as we move back, our LED comes on. We know our wire's path. We move down, and no matter what direction we move in, our red LED does not light as brightly as previously. So our short is going to have to be right below where the LED goes off, or actually lessens. Here it's on brightly. There it goes off. So right below here is where our short should be. On, it's off. Right here. So let's mark this. Well, before we do that, let's just, instead of having such great distance, because we have from here to here, we have a good 3-inch distance. Let's reduce our sensitivity and get down closer and see what we can get. You'll notice the lack of splatter here across our shielding, because we can easily discern our path of the wire. So this says we're right around here. So our short is right here. Let's mark this spot. mark it right there and remove our shielding so we can see how close we came. Okay, our marker says that we're here, which would be here on our wire, and our short, as you can see, is actually right there. So we're approximately 2.5 inches from our short. You'll notice that we're 2.5 inches in front of our short, not behind our short. So being able to find a short in an aviation wire through lead to within 2.5 inches is something that no other technology has ever been able to accomplish. The Wire Integrity Testing and Tracing System from McKenzie Technologies. Redefining possible.